Today we're going to start the first of a three-part trig lesson. So this is Trigonometry Notes Part 1. So an angle is formed when two rays meet at the same point called a vertex. The angle measures the rotation from one ray, which is the initial side, to the other ray called the terminal side. So we have our positive angles, which rotate counterclockwise, and we have our negative angles, which rotate clockwise. The most common notation for an unknown angle is theta, but we use other Greek letters, or we can even use variables like x, y, and t. There are two common ways of measuring angles. They can be measured in degrees, which is probably what you're used to, or radians, which actually have a lot more value to them. A central angle is an angle that's formed inside a circle where the vertex is the center, and the initial and terminal sides will form a radius. So we have a nice radius right here and a radius right here, forming this central angle theta, where the vertex is the center of the circle. When the radius is equal to the length of an arc that's formed by a central angle, then that central angle measures 1 radian. In other words, when this distance right here, this radius, is exactly equal to this arc S right here, when these two are equal, this angle theta right here measures 1 radian. So if we were to go halfway around a circle, we would have 1 radian, 2 radians, 3 radians, plus a little bit more. And that little bit more is about 14159. So we have 123.14159, which is pi. So halfway around a circle is pi radians. So then 1, 2, 3, 4, 5, 6 plus a little bit more, 1 full rotation around the circle forms 2 pi radians. So the most common conversions from radians to degrees is that 2 pi is equal to 360 degrees, pi radians is equal to 180 degrees, pi over 2 radians is 90 degrees, 3 pi over 2 radians is 270 degrees, pi over 3 radians is 60 degrees, pi over 4 radians is 45 degrees, and pi over 6 radians is 30 degrees. The key thing is, if you can remember that pi is equal to 180 degrees, then the rest of these conversions come naturally. So when we are measuring our angles, a lot of times we're going to put our angles in what's called standard position, where the vertex is going to be the origin and the initial side is going to be the positive x angle. So x-axis. So starting right here, if we start rotating counterclockwise, we're going to form our positive angles. And then here, starting right here, if we go clockwise, we would get our negative angles. So looking at the xy axis, broken up into 4 quadrants, quadrants 1, 2, 3, and 4. In quadrant 1, our angle would be between 0 and 90. In quadrant 2, we'd be between 90 and 180. In quadrant 3, we'd be between 180 and 270. And in quadrant 4, we'd be between 270 and 360, rotating counterclockwise. However, for negative angles, rotating clockwise, if we were in quadrant going backwards 4, this would be between negative 90 and 0. Quadrant 3 here would be between negative 180 and negative 90. Quadrant 2 here would be between negative 270 and negative 180. And quadrant 1 here would be between negative 360 and negative 270 degrees. Now, it's easier to speak about angles in degrees, but when we're doing math, a lot of our calculations are going to be done in radians. So I want you to get used to radians. However, if you would like to learn how to convert from degrees to radians or radians to degrees, well, to go from degrees to radians, you're just going to take your degrees and multiply it by pi radians over 180 degrees. And to go from radians to degrees, then you'll take your radians and you'll multiply it by 180 degrees over pi radians. So here are some examples. To convert 150 degrees into radians, I would just multiply it by pi over 180. Remember, in the previous piece of paper, we said that pi was equal to 180 degrees, so pi and 180 are the same. Something over itself is 1, so we're just multiplying by a fancy 1. But when we do this, the degree symbols will cancel, and we get 150 pi over 180, which is going to reduce to 5 pi over 6 radians. Negative 240 degrees, to go from degrees to radians, we will multiply by that pi over 180. Now the degrees will cancel, and I have negative 240 pi over 180, which will reduce to negative 4 pi over 3. To go from radians to degrees, we said we would multiply by 180 over pi. So we'll take that pi over 12 times 180 over pi, and then we get 180 degrees pi over 12 pi. The pi's will cancel, and we have 180 degrees divided by 12, which reduces to 15 degrees. But an easier thing to do, we can remember that pi is equal to 180 degrees, then we can just replace this pi with 180 degrees, and we end up with the same 180 over 12, or 15 degrees. Here for negative 2 pi over 3, you have a couple choices. You can take the negative 2, so we'll replace pi with 180. Take the negative 2 times 180 to get negative 360, divided by 3 to get negative 120. Or you can take the 180 divided by 3 to get 60 and multiply that by negative 2, and you still get that negative 120 degrees. Angles that share the same initial and terminal sides are said to be coterminal angles. So in other words, you're going to start and end at the same place. But angles can go around and around and around a circle again and again and again and again. So every angle has infinitely many coterminal angles. So I'm going to show you that a little bit more in depth up here when I had my angles here. So see this initial side and terminal side, and this angle has the same initial side and terminal side. Those two angles are coterminal. But what if I did this? What if I went one full circle around and then a little bit more? I would get another angle with the same initial and terminal side, and that would give me a coterminal angle. Here I could go backwards a full circle and then keep going, and we could do that basically infinitely many times. So every angle has infinitely many coterminal angles. And you can find your coterminal angles by just going around an additional circle, either in the positive or negative direction. And one full rotation around a circle, we said, was 360 degrees or 2 pi radians. So you can just add and subtract 360 degrees or 2 pi radians over and over and over again to get as many coterminal angles as you want. So let's do some examples of that. Let's find two coterminal angles, one positive and one negative, for each of the given angles. So for 225 degrees, we'll add 360 to get a positive coterminal angle for 585. And we'll subtract 360 degrees to get a negative coterminal angle of negative 135. Angles are pretty easy to work with, but again, as I've said, they don't have a whole lot of value to them. So we're going to do most of our math and most of our calculations in radians. So if our angle is 2 pi over 7, then I can find a coterminal angle by adding 2 pi. So I have a fraction. Here's where my fraction arithmetic is going to come in. I'm going to take that 2 pi over 7 plus 2 pi. In order to add fractions, they're going to have a common denominator, which is going to be 7. So 2 pi is 14 pi over 7. And then once the denominators are the same, I can do that 2 plus 14 pi to get 16 pi over 7. For our negative coterminal angle, I'll subtract 2 pi. 2 pi over 7 minus 2 pi is going to give me 2 pi over 7 minus 14 pi over 7, or negative 12 pi over 7. Oop, that's not working. To find my coterminal angles for 3 pi over 5, I can add 2 pi. Negative 3 pi over 5 plus 10 pi over 5 would give me 7 pi over 5. Well, what would have happened if we added 2 pi and we still got a negative? What would we do to get a positive coterminal angle? Add 2 pi again. And you can just keep adding 2 pi until you get a positive coterminal angle. And the same thing, you can keep subtracting 2 pi until you get a negative coterminal angle. So beta will be that negative 3 pi over 5 minus 2 pi, which gives me negative 13 pi over 5. If my angle is 7 pi over 3 and I want a positive coterminal angle, we could add 2 pi. That would give me 13 pi over 3. To find our negative coterminal angle, we could subtract 2 pi, which gives us pi over 3, but that's not negative. And I'm trying to find a positive and a negative coterminal angle. Right now I have two positive coterminal angles, so I just subtract 2 pi again to get negative 5 pi over 3, and that'll give me that negative coterminal angle. Some definitions. Two positive angles are called complementary if they add to 90 degrees or pi over 2 radians. And two positive angles are supplementary if they sum to 180 degrees or pi radians. It's very important that we notice that these two angles have to be positive. So you cannot deal with a negative angle. So if you wanted to find the complement and the supplement of, so we'll call the complement alpha and the supplement beta if it exists for the following angle. Just based on the definition, you can get the formula for finding the complement and the supplement. If alpha, and we'll call this one theta, if alpha and theta are complementary, then they add to 90 degrees. So looking for alpha, the complement would just be 90 degrees minus the original angle I was given, in this case 72, which we can see that our complement would be 18 degrees. Beta plus theta equals 180. So if beta plus theta, if they're complementary, they're going to get 180 degrees. So beta, the supplement we're looking for would be 180 degrees minus that original angle theta. Beta would be 180 degrees minus our theta 72, or we'd get that our supplement is 108 degrees. Now let's do it in radians. If I wanted to find the complement and the supplement of 2 pi over 5, well, alpha plus theta equals pi over 2 to get that complement. So the complement will be pi over 2 minus theta, which is 2 pi over 5. Subtraction with fractions, you need a common denominator. So I'll multiply the top and the bottom here by 5 and the top and the bottom here by 4. Once the denominators are the same, I can subtract their numerators over that denominator, and I get that the complement is pi over 10. For the supplement, beta plus theta would equal pi, so we can find the supplement beta by taking pi minus the original angle theta, which is 2 pi over 5. Getting that common denominator again, which is going to be 5, we see that our supplement is going to be 3 pi over 5. For 4 pi over 7, we can find the complement by doing pi over 2 minus theta, which gives me 7 pi over 14 minus 8 pi over 14, which gives me negative pi over 14. But remember what we said. We said that complements and supplements had to be positive angles. That's a negative angle, so that means that there's no complement. What does that mean mathematically? That means that this original angle theta here is bigger than 90 degrees. However, just because there isn't a complement doesn't necessarily mean that there isn't a supplement, so we can try to find beta by taking pi minus that original angle 4 pi over 7, which gives me 3 pi over 7. That is a positive angle, so yes, it did have a supplement. Now we're going to get into a big definition of the unit circle. The unit circle is the circle that is centered at the origin that has a radius of 1. And it's given by the formula x squared plus y squared equals 1. Well, I'll show you where that comes from. The equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where h comma k is the center of the circle, in this case the origin, so that's going to be 0, 0. And r is the radius. In this case, we said the radius was 1, so that's going to be r equals 1. So x minus 0 squared gives me x squared. Y minus 0 squared gives me y squared equals 1 squared is 1. And that's where that equation comes from. Now, for any point on that circle at all, you can take any point on here and call it an x comma y. And for that point, you can form a central angle in standard position where the initial side is the positive x-axis and the terminal side ends at that ordered pair. And we get this central angle theta. Now, the trigonometry functions, we have 6 trigonometric functions we're going to start with. We have the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. So for this ordered pair that I have right here, x comma y, the sine of this central angle is the y value of that ordered pair. And the cosine of that angle theta is the x value of that ordered pair. Sine and cosine are the 2 main trig functions. The rest of your trigonometric functions are all defined by sines and cosines. So once you know that sine, for any central angle that you can form here, the sine is the y value and the cosine is the x value. This is on the unit circle where the radius is 1. Once you know sine is y and cosine is x, then you can find the tangent, which is sine divided by cosine, Well, since sine is the y value and cosine is the x value, we get y over x. But of course, x can't be equal to 0 because we know we can't divide by 0. For the cosecant is the reciprocal of sine. So that's going to be 1 over the sine of theta, which we said the sine of theta was y, so the cosecant is 1 over y, and again, y can't be equal to 0. For the secant, we have the secant of theta, which is 1 over the cosine. The secant is the reciprocal of the cosine. And since we said the cosine was x, that means the secant is 1 over the x value for x not equal to 0. And then the cotangent is the reciprocal of the tangent. So the cotangent is 1 over tangent. Well, we said tangent was sine over cosine, and the reciprocal of that is cosine over sine, which will give us x over y for y not equal to 0. Now, the unit circle has infinitely many points on it, but what we refer to as the unit circle in general is this circle here that highlights a handful of them, about 16 angles that we highlight. 0, 30, 45, 60, 90, 120, 135, 150, all the way around. And so these are ordered pairs that have a lot of value to them and are very important. So when most people think of the unit circle, they think of this thing right here. Now, there's still infinitely many more points on here, right? There's an ordered pair here and here and here, right? We have 15 degrees or maybe 62 degrees, something to that effect. But these are the ones that we highlight on the unit circle. So if you're asked to do a problem, for example here, find the 6 trig functions for theta equals pi over 2, all we need is the ordered pair that goes along with pi over 2. So we find pi over 2 on this unit circle. We see that the ordered pair is 0, 1, and then that's it. That's all we need. So we can find all 6 trig functions for this angle pi over 2. The sine of pi over 2 is going to be the y value of the ordered pair, 1. The cosine of pi over 2 is going to be the x value of the ordered pair, 0. And then we can find the rest because tangent, cosecant, secant, and cotangent are all defined by the sine and cosine. Tangent, which was sine over cosine, is the y value divided by the x value, which gives you 1 over 0, which is undefined. The cosecant is the reciprocal of the sine, so it's 1 over the y value, so 1 over 1, which is 1. The secant is the reciprocal of the cosine, so that's 1 over the x value, which is 0, which can't divide by 0, so that's also undefined. And the cotangent is the reciprocal of the tangent, which we can see here, the reciprocal of 1 over 0 is 0 over 1, or we could just say x over y, 0 over 1, which is 0. Let's do another example. Let's find the 6 trig functions for theta equals pi. Again, we go back to our unit circle, and all we need is the ordered pair that goes along with that angle pi, which according to our unit circle is -1, 0. The sine is going to be the y value. The cosine is going to be the x value. Tangent is sine over cosine, or y over x, which gives us 0. Cosecant is the reciprocal of the sine, 1 over 0, which is undefined. Secant is the reciprocal of the cosine, 1 over -1, which is -1. And the cotangent is the reciprocal of the tangent, so instead of 0 over -1, that gives us -1 over 0, which again is undefined. Let's do another example here. Let's find the 6 trig functions for 7 pi over 6. Look at our unit circle. Find the ordered pair that goes with the angle 7 pi over 6, which is -√3 over 2, -1/2. The sine is the y value, -1/2. The cosine is the x value, -√3 over 2. Tangent is sine over cosine, or y over x, which is -1/2 divided by -√3 over 2. Now, we don't leave it as fraction over fraction. That is sloppy. So we're going to take that -1/2 and multiply it to the reciprocal of that -√3 over 2. Notice the 2's are going to cancel, and a negative times a negative is a positive. So this is going to give us 1 over √3. Now, while I'm okay with that answer, you're almost never going to see the answer written like that. Most mathematicians' textbooks and answer keys are going to rationalize this. We don't leave square roots in the bottom. So they're going to multiply the top and the bottom by the square root of 3. 1 times the square root of 3 is √3, and then √3 times √3 is going to give us 3. So the tangent of 7 pi over 6 is the square root of 3 over 3. The cosecant is the reciprocal of the sine, so instead of -1/2, it's -2/1 or -2. The secant of 7 pi over 6 will be the reciprocal of the cosine, so instead of -√3/2, it'll be 2 over -√3. And again, we'll rationalize by multiplying the top and the bottom by that square root of 3 to see that the secant of 7 pi over 6 is -2√3/3. And the cotangent is the reciprocal of the tangent. It is easier to take the reciprocal of the unrationalized form of the tangent. Instead of 1/√3, that would be √3/1, which gives us the square root of 3. So I'm going to come back up here to the unit circle. So looking at this unit circle, going around, right here is the y-axis, and right here is the x-axis. And remember that the sine is the y value. So the largest y value we have is 1, and the smallest y value we have is -1, and all the y values in between are accounted for. So the biggest value that the sine can be is 1, and the smallest value that the sine can be is -1, and it can be any value in between. For the cosine, which is the x value, the largest x we take on is 1, and the smallest x we take on is -1, and it has every value in between. So the biggest the cosine can be is 1, and the smallest that the cosine can be is -1. So when we look at that in terms of domain and range, the domain of sine and cosine is all real numbers. You can take the sine and the cosine of anything you want, right? So let me explain that to you, coming back up to that unit circle. Here we've got 0 degrees, 1 degree, 2 degree, 3 degree, 15 degrees, 30 degrees, 31, 32, all the way to 90, to 180, 270. Here's 350, 370, 350 right here, 351, 52, 53. Here's 360. And then we get 361, 2, 3, 375, 390. And what ends up happening as you're going around is once you get past 360, you start going around again. And once you get past 720, you start going around again and again. And the same thing backwards. Go all the way to -360. Once you get past -360, you're going around again. So the domain is all real numbers. You can plug in anything you want and take the sine and the cosine of any number on the entire real number line. However, for the range, as we said, your output is always going to lie between -1 and +1 for both of those. A function is called periodic if there exists a c such that f of x plus c is equal to f of x, and the smallest such c is called the period. Sine and cosine are both periodic functions with a period of 2. That means that your sine and cosine values will repeat every 360 degrees. So I'm going to come back up here to the unit circle to kind of explain that a little bit more. Here is 30 degrees, which is pi over 6. The sine is 1/2 and the cosine is √3/2. Now, what if I added 360 degrees to that? What if I looked at 390 degrees? So 390 degrees, I would go all the way around the circle for 360 degrees plus 30 degrees more, and I end up right back here at that exact same ordered pair that has the exact same y value, so it has the exact same sine, and the exact same x value, so it has the exact same cosine. And so if you do that for any of these on here, you will see that the sine and the cosine are going to repeat every full rotation around a circle. So we call that being periodic, and sine and cosine are periodic with a period of 2 pi. So what does this mean? Trig functions of coterminal angles are the same. If you have the same x value and the same y value, then you're going to have the same sine, cosine, tangent, secant, cosecant, and cotangent. So let's look at some examples here. Let's find the cosine of 7 pi over 3. If you go back to your unit circle, you're going to see that 7 pi over 3 is not on the unit circle. So you're going to need to find a coterminal angle that is. Well, how do we find coterminal angles? We add or subtract 2 pi. Well, if I add 2 pi, I'm going to get a bigger value here, and we can already see that 7 pi over 3 is too big. So we'll try by subtracting 2 pi, which gives us pi over 3. Pi over 3 is on the unit circle. And since trig functions and coterminal angles are the same, the cosine of 7 pi over 3 will be the same value as the cosine of pi over 3, which we can see is 1/2. If we were going to try to find the tangent of negative pi over 4, again, we pull out our handy-dandy unit circle and we can see that negative pi over 4 is not on the unit circle, so we'll find a coterminal angle that is. Well, the unit circle has all positive angles, so we're going to try to find a coterminal angle that's positive by adding 2 pi, which gives us 7 pi over 4. That is on the unit circle, so the tangent of negative pi over 4 is the same as the tangent of 7 pi over 4, which is the y value divided by the x value. And negative root 2 over 2 divided by positive root 2 over 2 is going to give us negative 1. I'm going to stop the video here, and I have a second video that'll finish these trig part 1 notes. So I'll see you next time.